Good day, stat students. So we're going to talk about section 9.2 part 3. So this is running the second hypothesis test for the population portion P. So greetings card companies such as Hallmark or maybe American Greetings is concerned over the percentage of people that sends Christmas cards in the mail. In order to turn a profit during the season, the company needs more than 15% of all households in the U.S. are still sending Christmas cards in the mail. The company randomly selects 400 U.S. households and finds 80 still sends Christmas cards in the mails. Test at the 1% significance level. If more than 15% of all households in the U.S. still sends Christmas cards in the mail. Okay. At that point, they think they can get enough market share and turn a profit during the season. All right, let's go through our background information. How do we know we're conducting a hypothesis test? Well, it says that we're going to go ahead and test at a certain significance level. Okay. What's our variable? Does a household still send Christmas cards in the mail? And it's a yes/no question, categorical. We have to analyze with a percentage or proportion. So the population portion P we're going to be testing here. What's our sample? 400 U.S. households. So the N is equal to 400. And if 400 U.S. households is our sample, what's our population? All U.S. households. What would be a success? So finding a household that still sends Christmas cards in the mail. Okay, how many did we have in our sample? We had what? Let's see. There's our sample, and how many successes did we have? We had 80. That's X. Okay? All right. That means we can calculate p hat as sample proportion. So let's see. 80 over 400. That's 0.2 or 20%. So 20% of our sample of U.S. households are still sending Christmas cards in the mail. Okay? All right. So there's our background information. Let's get into more specifics. Step 1, state the hypotheses. So it says here test at the one if more than 15%. So that sounds like P is greater than 0.15. P is standing for something. That's the percentage of all the U.S. households that are still sending Christmas cards in the mail. Instead of writing that out, we're just going to use that symbol to represent all those words. We go back to the null. Remember the null is h sub 0. That would be P is equal to 0.15. Okay. And we are clearly running a right tail test because we have a greater than sign. We're going to use that information when we calculate the P value, the probability value. Okay. Step 1. Step 2. We have to check the conditions. Let's go ahead and check our conditions. So random sample, we either need a random sample or that the information was obtained through an experiment. Let's see here. The company randomly selects. There we go. Okay, check mark. It's randomly done. 2, we got to verify the CLT. Make sure that the sampling distribution of P hat is approximately normal. So we got to verify that n times P sub 0 is greater than or equal to 15 and n times 1 minus P sub 0 is greater than or equal to 15. Remember that that's different than the confidence interval. Okay, just reminding you. All right, so n times P sub 0 here is 60, so we got 400 times 0.15, 0.15. So remember 0.15, let's go back to the null hypothesis. Remember what's in the null? Remember P sub 0, 0.15. Okay, so that's why I have here 400 times 0.15. That's 60. That's greater than or equal to 15. Check mark. We got to verify that n times 1 minus P sub 0 is greater than or equal to 15. That turns out to be 340. That's greater than or equal to 15. Check mark. That's telling us that the central limit theorem is applying and the sampling distribution of P is approximately normal. Yay! We get to use the formula that I've been showing you instead of using other methodologies, which is meant for another stats course. We go to step 3. Step 3, calculate our test stat. There's our test stat. We can use this because the central limit theorem applied. There's our background information again as far as the null and the alternative hypotheses, because we're going to need the value in the null to place in for P sub 0. Sample proportion was 0.2. It says calculate our test statistic. So we got 0.2 minus 0.15. Okay, then you calculate your standard error. Again, not rounding anything here, even though I showed it to 4 decimal places. When I calculated this, I did not round anything. It turned out to be 2.80. 2.80. Now I want to warn you of something. Okay, I may have warned you this back in section 9.1. Okay, so we are testing if p is greater than 15%. Okay, and our p hat turned out to be 0.2. That doesn't mean automatically that we get to reject the null hypothesis just because p hat is greater than the value of the null hypothesis. Okay, what would have happened if our p hat was instead of 0.2, it turned out to be 0.150000001? Well, yeah, okay, that's greater than 15%, but remember that just came from a random sample of 400 U.S. households. Is it possible that for all households that it could actually be less than 15% at that point? So remember, you got to have convincing evidence from our sample that it's greater than 15%. Okay, and so just reminding you of some concepts there. Okay, so our test stat turned out to be 2.80. What's our interpretation? The sample proportion p hat is 2.80. Standard error is above the value in the null hypothesis. It's above the null because it's positive. Hopefully you're getting familiar with interpreting your test stat now. Alright, calculate the p-value, your probability value. Alright, there's our test stat again. And so let's see, we have a right tail test. So let's see here. We'll go ahead and try to depict this. That wasn't too bad. Here's 0. Excuse me, here's z, here's 0, here's 1, here's 2, here's 3. 2.8 is way out here. Okay, you should always put a scale to make sure that everybody understands. So we have a right tail test. Again, that's looking, that shaded area, okay, isn't looking like it's a very big area underneath that curve, does it? Okay. And so it looks like our p-value is going to be pretty small here. Alright, so we go to our table. Get your standard normal table out. Look up a positive 2.80 unless you want to use the idea symmetry. 2.80. Alright, here's 2.80. 0.9974. But you already should know that that is not the p-value. Okay, that is not the p-value. So 0.9974 is this area right here. 0.9974 is this area right here. Why? Because remember, the book is always giving us what? It's always giving us less than. We want greater than. It's right-tailed. So what's our p-value? 1 minus this value right here. So I got here 0.0026 is our p-value. 1 minus 0.9974. Sounds like a small p-value. Alright, so our conclusion. Just reminding you of some stuff. Okay. So here the p-value is equal to 0.0026, which is less than 0.01. Company really wanted to be convinced by setting it to 0.01. I'm not sure if businesses would actually do that. But here, remember, we get to change the alpha a little bit just to make sure that you got the concept down. Maybe in business they would set it at 0.05, but here we're setting it at 0.01. So we're going to reject the null hypothesis. Remember what that means. We have strong evidence of something. Okay? We think that the statement in the null is wrong, the alternative is correct, and we have strong evidence at the 1% significance level that the percentage of all U.S. households that still sends Christmas cards is what? Is more than 15%. So notice here, all I said is that we have strong evidence that, I'm going to put this in parentheses, that the percentage of all U.S. households that still sends Christmas cards, notice, all that is P for the problem. So all I'm saying is that we have strong evidence that P is more than, greater than 15%. That's it. Okay? And I'm just putting it in words. Alright? So there's an example of a right tail test. Okay, the next one that we'll do is probably going to be for a two tail test. All right, well, thank you for your time. That ends this problem.